All right, next on our agenda is Greg Purdom, and he's going to be talking about the black box. Greg, I should have given you access. You should be able to share your screen.
Okay, do you see it?
Yes.
Okay, let me start this. Okay, I'm going to talk about the black boxes that were made in Sarasota for about 38 years. About half the black boxes for airplanes were made in Sarasota, and they just moved the factory out this past year. But this first slide here shows 3 generations of the cockpit voice recorder. And the first generation here on the left was a tape recorder. And that design was in the 60s. It continued through the late 80s. And this was fashioned after an 8-track tape recorder, if you remember those in your cars. The tape was pulled out from the inner part of the reel and goes around all these pulleys and rollers and across heads, forward heads, playback heads, and erase heads, and then back onto the outer portion of the cassette. And it was designed originally for 30 minutes. So after recording has been made 30 minutes, it wraps back around and it gets erased and re-recorded. And so you had the last minutes of recording. And then when the pilot landed the airplane and the wheels were on the ground, there was pressure on the wheels and the plane knew that it was stopped. There was a button in the cockpit that the pilot could push and erase the whole tape at one time. And this was the erase mechanism to bulk erase the recording. Of course, if there was a crash, then it wouldn't be erased. This outer white part here called a water pack, and that's what protected this unit in a fire. Now the covers have been removed, so we're seeing inside this recorder, but on this side of the recorder, there would also be another one of these water packs, and then a stainless steel housing to protect it. And now over the whole recorder, there would be another stainless steel housing put on it, and that would be painted orange. So as everybody knows, the black boxes are really orange. It helps the investigators find them, at least if there hasn't been a fire. Then this tape recorder eventually gave way. Whoops, sorry, skipped a slide. This tape recorder eventually gave away to solid state recording. And this was one of the first solid state designs that used flash memories. And this was designed in the later 80s. And of course, a different crash housing was made to protect it. You can see this is smaller than the old tape unit. The tape unit had a housing that fit about that size, and this became smaller. And the tape unit had 4 channels of recording. Here's the audio processing. And in this unit, all the audio was digitized and it was recorded digitally instead of analog, like the old tape recorders. And this box was designed for up to 2 hours of recording eventually in place of the 30 minutes. Now, I'm showing the cockpit voice recorders. There's also a data recorder that can record up to 1,000 parameters per second. The recorders look very much the same. It's just the electronics portion is a lot longer for a data recorder, and I'm only showing the cockpit voice recorders. Then after about 10 years of this, we changed the design again to make it smaller and lighter. And this unit was designed, and this is the unit, the housing that replaced this or the tape. And this was much lighter weight. This whole recorder less than 10 pounds. When we started out, this was about 30 some pounds, almost 40 pounds. This reduced weight, and this really reduced weight. And you'd think, why do you care about the weight in an airplane? They're so big. Well, all this electronic equipment flies for free, and they have to pay gas on that. So every pound you save over the life of that airplane saves them a lot of money. So they're always happy to see us reduce the weight. And there's another cover that goes over this, another orange cover. So this box then gets loaded. These screws here get loaded. Now I've jumped to the next slide, so I'm going to talk about this slide now. Here's kind of a cutaway diagram of a cockpit voice recorder, that the current crash housing design. In the rear of the recorder, this is where it plugs into the airplane. There's a conditioning board. I guess I'm nervous. I'm tapping it and it's moving on me. This is where the box is plugged into the airplane, and all the power and all the signals come in through. So all the lightning protection and the power supplies in this first board, and then that power is then moved on to the computer board, which is number 3. And then the audio signals are moved to this audio compressor. And this is where the audio signals get digitized. And then those signals get sent to this computer board. And this was designed with an Intel 186 processor, be real low power. This whole unit only operates with less than 10 watts. And that's an important too, because when the power goes out, we want to save enough energy in this energy storage device, which is a large capacitor. This isn't to scale, it's much bigger than this. It saves the energy to allow the recorder, if it senses the power going out in the airplane, it has to shut all the files down. And so when you try to recover the data, the files aren't all messed up. It does a good job of shutting everything down and closing all the files so they can be read when the accident investigators try to read it. Now here is the memory board. In this case, we have stacked memory. There was 15 different flash memory chips on this board, and I'll show the details of that a little later. But we had to use 4 different boards stacked. The goal was to get the volume, the outside volume of this as small as possible, so it would take in less heat energy during the fire. And this part is the crash housing that protects against the crash. Inside, we have some insulation here that protects against the fire. On the front of this unit, this item 6, that's the underwater locating beacon. That has a battery in there and a pinger. And when this unit senses it's underwater, it starts sending out a pinging signal to help sonar units find this device. And here's the switch, the water switch that turns it on. It sort of looks like a battery with a little button in the middle, but this area in between is a specially shaped dome of Teflon. So water can't stand in there and artificially turn that switch on and run the battery out. I'm going to go to the next slide here. And this slide represents one of the first tests that you do when you're certifying a crash design. And we're going to simulate an airplane crash, which is 3,400 G's impact. And to do that, this is at the University of Dayton Research Institute. We had them build a cannon for us that's 40 feet long. This tube here is 40 feet. That's twice as long as your garage. And the inside diameter is 12 inches. And then at the end, at the far end down there, we have a containment cage that's about 6 feet long. And there's bars there to catch all the debris that comes down, the large chunks anyway. And we place a honeycomb target in here. This is aluminum honeycomb. It sort of looks like aluminum cardboard. And it's specially shaped and designed to give us the right profile of the impact. And so at the end of this and they shoot a laser down here and line up the point of that comb with the center line of this barrel. And they also go down and check to make sure there's no sway in this barrel. There's sections here that look like these yellow things where you can dial in the alignment of that barrel. So we have to line it so it's So it's a pretty good straight shot, and we use a laser for that. Then we mount that crash housing from the previous picture in a sabot. And a sabot is sort of like a bucket. We mount it in the bottom of a bucket and then place the bucket in here. And then we cover this flange with mylar. It's a heavy plastic. And then we put a air pressure tank, a large tank, much larger than this here, and bolt this together. And before we do that, we place a nichrome wire in here, sort of like the wire in a toaster. And we heat that wire up real fast with a special circuit, and it makes that plastic soft, and the air in the air tank blows that plastic through and pushes the sabot down with the crash housing in it, down to the end of the cannon. By the time it gets down there 40 feet, it's going 350 miles an hour, which is 513 feet per second. Think about that. That's 1 2/3 football fields length every second. And then we stop that in 18 inches. It takes about 6.5 thousandths of a second to stop it. But there's a lot of energy being dispersed right here. And it smashes that honeycomb down. And we have force gauges here to measure the force and use computers to analyze all that data. And then before it hits the target, we have 2 lasers with lights to measure the speed. Make sure that's the right speed we get. So I'm going to go to the next step. And this is a second of a video that was made by Channel 13 in Tampa at the facility in Sarasota. And I cut out a couple different pieces, but this is going to be the pin drop. This would be the third test in the sequence. Now this box hasn't really gone through the other testing. This is all just for show to make this video. But what they're going to do is try to penetrate this outer casing. Remember, our memory's inside here, and that's what we're trying to protect. Now we're going to do a penetration test. They're going to be a 500-pound weight raised 10 feet in the air with a 1/4 inch diameter steel hardened pin that's about 1.5 inches long. Let's watch this video here.
Outside the factory,
Flame test.
Ooh. I'm having some technical difficulties here. Do you have the sound now, Hewie?
right here,
Yeah, yes.
a 500-pound weight will fall from 10 feet, simulating sudden impact at 310 miles an hour.
What's it going to sound like?
It's a thud. It's more impressive sound-wise than it is visual.
A pin attached to the weight aims to pierce the recorder's skin.
The plan is to hit the middle of this L3 logo.
The trial is as fast as it is simple. And successful. The encased cylinder withstands the crushing force.
You want it to pass.
We want it to pass.
Okay, then there's a few other tests, but the next test that they showed on the Channel 13 was a fire test, and we'll watch that now.
Outside the factory,
Flame tests.
3 gas-powered torches fuel a raging fire.
How long does it go?
This is a 1-hour fire test.
The flames burn blue, even hotter than ignited jet fuel.
It's specified to be 1100 degrees C, which is just over 2000 degrees Fahrenheit.
Over time, the housing melts into a puddle of liquid aluminum. The memory unit, meanwhile, turns white hot.
That should do it.
But it survives.
The cylinder stays.
Cylinders, it will stay intact.
What matters?
That was the part that matters.
Okay, now here are some of the additional tests that have to be run on it. They do a static crush where they apply 5,000 pounds across the 6 major axis points. And really, if you can stand that 3,400 Gs, this is a no thrill test at all. Another thing that you have to do is survive a fluid immersion. One of the things that might happen after a fire is the firemen come in and put the put the fire out with a fire extinguisher, but some of the chemicals they use or some of the lubricants in the airplane drip on the box and ruin the recording. So you have to be sure you can withstand all of those things. So we had to get all kinds of different jet fuels and all the different oils and greases and lubricants and fire extinguisher stuff and test the components. And now here's the one of the 15 flash memory chips right here from this design. Now this is an older design. It was probably almost 20 years ago now that I did this design. And this pack of 4 boards has been replaced by 1 board now because the size changes in flash memory. But this was a long time before regular computers were used in flash memory. Another test we have to survive is a 9,000 PSI deep sea pressure test to simulate being underwater. Now, here are some pictures from an actual crash report that was written about a helicopter that crashed. Unfortunately, there were no survivors in this crash. And you can see that the crash housing is still intact here. A lot of the other metal and the circuit boards are all kind of charred and burned up. And here's the crash housing again. And here's the wires that come out of the crash housing. All the covering of the wires is gone. And this is with this lid removed in this view and a piece of insulation. And we see this little puck here where the memory is. And here's a view of that close up. And there's a little stick here because we have this on here to warn the investigators if this has turned black, which it has, it means that the temperature that this saw was above the melting point of the solder on these boards. And you can look over here and the solder's in pretty good shape except for this one piece right here, this bigger piece of solder. Now what happens, we have done a vacuum deposition, a coating on everything. So there's a real thin, high temperature plastic coating on everything. So when the solder melts, it's really trapped. And when it freezes again, it's right back in the same place it started at. And that helps us be able to recover this data without having solder bridges or gaps. But you can see what happened is some of these labels really delaminate, even though these are high temperature labels. And this is the remaining of the ribbon tape. They'll cut this off and then resolder a new ribbon on there to hook it up to the computer. But this is in good enough shape that wouldn't even have to be disassembled and cleaned. It would work as is right there just by establishing a new connection cable. Okay, that's the end of my show. Is there any questions about this?
Greg, was this Schlumberger? that
Yes.
manufactured these?
Yes, this
Okay.
was originally was Schlumberger. Schlumberger owned it, a location on Cattleman Road, just south of Fruitville. And
Right.
that was in the late 50s, I think. And this product line, I came down in the 78, I was transferred down, and this product line was transferred in 81. And then over the years, Schlumberger sold it to Loral Data Systems, and then Lockheed Martin bought it, and then it was spun off as L3, and then L3 is combined with Harris, so it's L3 Harris. But the part of the buildings are still there. They had 80 acres out there, and they sold off a few years ago. They sold off some of the land, and some of the buildings are still there, but L3 is long gone now.
And was any of this work done in secret?
Pardon?
Any of the work done in secret, or was it all?
Not this. This work was only this kind of one company would keep from another company, but there was also some classified work being done for the military, and some of the recorder work we did there. But that part left before this part.
And
was classified work
you worked
done.
for them for a long time or not?
Pardon?
Did you work for them for a long time?
Yeah, yes, I worked for Schlumberger 9 years and then was transferred down here and worked another 30 some years for, well, eventually it wasn't Schlumberger anymore. There was several different owners, but I have a lot of business cards with everything the same except the name of the company. You know, there's 2 locations, 40 years of locations, but a lot of different company names.
Okay, just a funny personal note. I taught French to some of the Schlumberger employees at one point in time. This is Judy Stratton.
Oh, yeah,
Okay.
yes. That's where,
Okay,
that's
good.
where the headquarters was.
Yeah. Okay. Thanks.
Greg, how many of these units were manufactured in a year?
Oh, I can't remember, but there was like 80,000 of them made here over the whole time, I think.
Wow.
And that's not counting the ship recorders. We made about half of the aviation recorders, the cockpit voice recorders and the flight data recorders, but we made about 80% of the recorders that go on ships. You don't hear as much about those, but that was a big business.
Why is it called a
Fascinating.
black box?
Pardon?
Why is it called a black box?
Well, years and years ago, it was instead of trying to describe what was in it, it was sort of like, well, this is a magic box. You don't, it's too complicated for you to know about. So they called a advanced electronic products a black box, and that was meant something back in the 50s, but it's just sort of a name that stuck with it.
And what does one of these cost approximately?
It can be in the $30,000 to $40,000 range. Can be less depending on what kind of data you want recorded and how many of them you buy and so forth.
And is it required over a certain size airplane?
Yes, in the case of it has to do with paying passengers first of all, and then smaller planes just have to have a voice recorder, and larger planes have to have a data recorder. And but when you get into ships, you know, there's things like ferries and all sorts of little, we would call them little boats in the rest of the country, but some of those have to have recorders.
Thank you very much, Greg. What a great presentation and a very unique product. We don't hear a lot about other than when there's an accident, the black box, they found it or they didn't find it. So,
Yeah.
I'd like to make a comment on that real quick.
okay.
My understanding was the moniker of black box was put on it because that's what the first responders found. They did not find an international orange device. They found a black device. And that's what
That
they
could be very
referred to it.
true.
It was never
That could be
black. It
true.
was always
Yeah.
international orange by federal law.
Yeah.